Hello students, our next chapter is wave optics. Optics means it is the branch of physics which deals with the study of light. Wave optics means wave nature of light. Here we are going to discuss. Previous chapter you learned that light travels in straight line, and there we discussed ray optics. Why we are considering ray optics, wave optics like that? First we will say that you know that the wavelength of visible light was measured and found to be extremely small. The wavelength of yellow light is near about 600 nanometer. But when you consider the size of the object around us, the size of the object is almost more than that. So there is a basic concept for wave. The wave bends around an object only when the size of the object is comparable to the wavelength of that wave. Incident on lenses, mirrors. When you consider the dimensions of lens and mirror, the wavelength of light is very small. So when we consider the light incident on lens, mirror, that time the light is not bending around that lenses and mirror, and we consider that light travels in straight line. This is the basic concept of geometrical optics. The branch of optics in which the finiteness of the wavelength is completely neglected. That means here we are considering the wavelength lambda is tends to 0. That is the basic concept of ray optics. Now you know that almost you can hear the sound of a person who is talking from the next room, but you cannot see who is in the next room. That is, the wavelength of sound wave is very much higher than the light wave. So the sound wave usually bend around the obstacle. That means you can hear the sound of a person sitting in the next room. But the light coming from that, it cannot bend. Why? Because the wavelength of light is very less. So few phenomena of light like diffraction, that is bending of light around the edge of the obstacle, formation of geometrical shadow. You know that when you get the shadow of a spherical body, the shadow is not perfect circular shape. You know that on the edge it is somewhat fuzzy. That means the light is encroaching into the geometrical shadow. See here that only I have shown here. We expect a complete circular shape, but we will not get a complete circular shape where the edge is irregular because the light is encroaching it. That is diffraction, the encroachment of light into the geometrical shadow. Then other one is that when waves interfere, that means superposition of waves, that also we can explain on the basis of wave theory. So this phenomena shows the wavy nature of light. Other than that, we have a polarization. Polarization is another phenomena. It shows the light is a wave and what type of wave is light. That shows light is a transverse wave. So here it is written here, the micrometer size obstacle will not be able to stop light ray. If the obstacle is much larger, however, light will not be able to bend that extent and will not be seen on the other side. Is equal or less than the wavelength of the wave. This is the basic concept of wave optics. Know that wave nature of light is explained by XII Huygens. And here we are going to explain the original formulation of wave theory according to Huygens. Here we will see how he explained the wave propagation. When you drop a stone on still water, then you know that ripples are extending from the point of disturbance to outwards. The same way, the light wave, it is extending from the source of light to outwards. Here, this is the point of disturbance. According to him, the source of light is the point of disturbance, and he told that is the wavelet. Then from this point, the wavelets originate, and after a particular time, it reaches the surface of a sphere whose radius is finite. That means these all points are equidistant from the point of disturbance. That means this is the surface of a sphere. The locus of all points which are in the same state of vibration, that he called wavefront. Then each point on the wavefront, it acts as the source of secondary disturbance. That means from each point on this surface, again secondary wavelets will be sent forward and it reaches the surface of another sphere. That is the secondary wavefront. This way, the light spreads from the point of disturbance to the destination. This is the concept of Huygens principle. Here, the wavefront, that is the locus of all points which are in the same state of vibration, that is the wavefront. The wavefront and the ray both are perpendicular to each other. That means the energy is spreading in the direction of ray that is perpendicular to the wavefront. This is few important points. What is wavefront? A wavefront is the locus of points having the same phase of oscillation. Then what is wavelet? A wavelet is the point of disturbance due to propagation of light. Then what is the direction of ray? Ray is perpendicular to the wavefront. What is the nature of the wavefront? See, here the source is a point, so wavefront is spherical in shape. Here cylindrical wavefront, so source is a linear source, otherwise a rectangular opening also you can consider, that is a slit. The wavefront from a slit is a cylindrical wavefront. Then the object is at infinity. The right rays are coming parallel. That means wavefront is a plane wavefront. When the object is placed at the focus of a convex lens, then the light rays are coming here, and after refraction the rays goes parallel to the principal axis. So here there is a plane wavefront. The same way, if the rays are coming from infinity and after refraction through a convex lens, the rays converges at the focus, so it is a spherical wavefront. According to Huygens principle, we can see the shape of a wavefront at a later time. Here, how we are going to construct the wavefront. Here F1, F2 shows a wavefront. Now each point on this wavefront acts as the source of secondary disturbance. Now each point, here we are considering the points equally distant. Then this each point acts as the source of disturbance. You take this as the origin and a particular length as radius. That length means we want to find out the position of the wavefront at a later time t. That means c is the velocity of light, and then distance, that is the radius of this arc, is ct. Draw a circle with this as center and radius ct. You can see that this way arcs are formed. Now draw the tangent of these all arcs and join that. You will get the next wavefront. Now each point on this wavefront acts as the source of disturbance. It sends out wavelets in the forward direction. This is the construction of Huygens wavefront. Same way here also explain. Here there is a plane wavefront. Then F1, F2 is the first wavefront. Then equally distant point A1, B1, C1, D1. Then this all point acts as the origin and CT as the radius. Again make arc. Then make the tangent. Then join all the tangents. You will get the position of the next wavefront. Here it is explained. This explanation you have to learn it. The Huygens principle is essentially a geometrical construction which, given the shape of the wavefront at any time, allows us to determine the shape of the wavefront at a later time. This I told you, at a later time you can find out the nature of the wavefront. Let us consider a diverging wave. This is the diverging case, diverging wave, and let F1, F2 represents the portion of the spherical wavefront at a time t is equal to 0. Now according to Huygens principle, each point of the wavefront is the source of secondary disturbance, and wavelets emanating from these points, that is originating from these points, spread out in all directions with the speed of the wave. These wavelets originating from the wavefront are usually referred to as secondary wavelets, and if we draw a common tangent to all these spheres, we obtain the new position of the wavefront at a later time. We wish to determine the shape of the wavefront at a t is equal to tau. We draw a spheres of radius v tau from each point on the sphere. Here see this as the center and v tau as the radius. We can draw spheres. Then the tangent of all these spheres, that gives the wavefront. This already I explained you. Then according to Huygens, the wave propagated only in the forward direction. He gave the explanation like that: the amplitude is maximum only when the wave propagated in the forward direction. The amplitude of the wave is 0 in the backward direction. Here he couldn't explain properly, but according to his explanation, Huygens argued that amplitude of the secondary wavelet is maximum in the forward direction and 0 in the backward direction. By making this ad hoc assumption, Huygens would explain the absence of back wave. According to Huygens, there is no propagation of light in the backward direction. This is the explanation of wave theory.